is Module 8, Lesson 4. We're going to compare properties of linear functions. We're just going to go back and look again at example 4 because this will make example 5 a little bit easier. If your two functions are linear, that means they're a straight line. You can see that clearly in the graph, but you can't necessarily tell from here, but they're telling you they're linear. Fine. Once you establish that the graphs you are comparing are both linear, then there's only three things you need to look at. Where do they both cross the x-axis? Where do they both cross the y-axis? And what is the slope? When you find where they cross the x-axis, write them both down explicitly. F of x is this number, g of x is this number, and then just write a sentence about which one is further to the right. So, from the table, when we have x-intercept, remember, how can we tell where that crosses the x-axis? It will cross the x-axis when y is 0. So you go down and you see, when is y 0? There. That is when the y, or f of x, is equal to 0. That means x is 3. So we're going to write that 3 here. You write it down explicitly. The x-intercept of f of x is 3. The x-intercept of g of x, well, we draw the line, we see where it crosses, it's -2, and we write it down explicitly. That means just make it absolutely clear. You write it down in the answer. And then just a quick sentence to say, so if we have -2 there, but the other one is at 3, I don't need to draw that line. I don't need to know, nobody asked me to draw the line for this function here. I just need to know where did it cross the axes, that's all. So let's get rid of that. And it crosses at 3, +3, and so we can write that f of x, this one here, this function here, intersects the x-axis at a point further to the right than g of x, because it's all the way here, whereas g of x here, is back there. And the same thing for the y-intercept, only we're going to be looking, so this is further, who is further to the right, and when it comes to the y-intercept, it's who is higher up. So first of all, tell me explicitly, where do they cross the y-intercept? Remember, so from the graph, that's quite easy. That's at the number 4. You only need the y value. How high is up? How high up is it? 4 units up. From the graph, we know that at the y-intercept, x equals 0. So x is 0, that means y is -1. So this is going to cut here. Again, I don't need to draw the line in, or I don't know how steep it is, I don't know what it looks like. That's not a problem. I just know that g of x, therefore, is much higher up. So I write, so g of x intersects the y-axis at a higher point than f of x. Literally, just take the sentences, copy it down with the numbers that you have. And finally, the slope. And if you remember, the slope is y2 minus y1 over x2 minus x1. You're going to have to work that out for any 2 points on here. You could choose these 2 points. Points with zeros are nice. And from here, you could choose these 2 points. You will find that f of x from the table is 1/3, whereas g of x from the line, from the graph, is 1/2. And so if you compare the number 1/3 to 2, clearly you can see that 2 is bigger. So 2 is the steeper graph. It is steeper, or it has the greater rate of change, or it has the greater radiance, or is increasing faster. Any of those will do. So once again, sentence, each function is increasing because they're both positive. So there's no negative slope here. We're getting bigger and bigger and bigger. But the slope of g of x is greater than the slope of f of x. So this is f of x, this is g of x. G of x is clearly bigger or greater. So that means g of x is actually increasing faster than f of x. So just go back to example 4, take the sentences but use your numbers. Okay, so you have lots of examples to fill in Classkick. Please have a go at that. Questions 11, 12 and 13 from practice. Okay, so this leads us nicely onto example 5. And if you see example 5, how does it relate? We're going to compare properties of nonlinear functions. Okay, so we've dealt with linear. If it's linear, you only need these three things: x-intercept, y-intercept, slope. If it's non-linear, we need a few more things, well, one more thing mainly, and then we just need to write the comparison. So here we go. Examine the categories to see how to use the description and the graph to identify key features of each function, and then complete the statement to compare the two functions. So once again, we've got some information here. So they actually give us the numbers. But here we have a graph, so we're going to have to take the numbers, read the numbers off the graph. So this is f of x. We will read down here. It's telling you that the x-intercept is at minus 3.4. It's telling you that y-intercepts at 1.5. It's telling you the relative maximum occurs when x is minus 2.3 and y is 4.7 high. Same thing with the minimum. X is minus 0.4 and y is 1.1. And then it tells you the end behavior. So let's count these. We've got the x-axis, we've got the y-axis, we've got this new thing, relative maximum, relative minimum. They kind of go together, x-y intercept, max min, and the final one is the end behavior. End behavior. What happens as x goes to minus infinity? What's happening to the y part? Well, in the function f of x, which you don't have a picture for, they're telling you as x gets smaller, so we can picture this, as x gets smaller, y gets smaller. So you're kind of going like down like that. Okay. Also on the other end, as x gets bigger, y gets bigger. So maybe looking at something like that on that side. Okay. All right. You can see from here, we're going to read off where is the x-intercept. It crosses the x-axis at three places, minus 1, 1, and 2. So remember, at the x-intercept, y will be 0. And so we've got 0, 0, 0. Okay, so we've got minus 1, 1, and 2. So just list them. Just list them. And then the y-intercept, g of x intercepts at 1 point, which is here, 4 high, 0, 4. Remember, at the y-intercept, x will be 0. Okay, so what about the extrema? What is the extrema? The relative maximum, the relative minimum. We can clearly see on our graph here that we've got a maximum point here and a minimum point here. Let's find out what those coordinates are. So we've got here, it looks like we are at 1, 2, 3, 4, 4 high. So that's probably about 0, 4 maybe. What do they say? Maximum at 4.2. So a little bit higher than 4. Okay, 4.2. Let's take their word for it. And when we go down, there's 1. So they're saying about minus 1.2. There's minus 1. So maybe a little bit smaller than that. Minus 1.2. Okay. So at the moment, we're just listing, and afterwards we'll make the sentences. Let's keep going. One last thing to do. So remember, group these, girls. It's easier to group it. XY intercept. Next one is maximum minimum. And the last one is on its own is the end behavior. Okay, so group them together. That will help you to remember them better. Not so much to remember. Okay. And then just write them all down on each side. If you've got a table on one side or a list on one side, write it on that side. And for the graph, write it on the other side. Let's keep going. So the end behavior, it told us explicitly, no need to work anything out. We just literally copy paste that there. What about this graph? Well, same thing. As x is getting smaller, y is getting smaller. Same thing there. And as x is getting bigger, or sorry, in the other way round, as x is getting bigger, y is getting bigger. So same thing, as x is getting bigger, y is getting bigger. So it's the same behavior, the end of the curve. So now all you have to do is write a sentence on each. The x-intercept of f of x is less than any of the x-intercepts. So this one here is minus 3.4. And that is smaller than minus 1, 1, or 2. So the x-intercept for f of x is smaller than any of the x-intercepts. Yani it's more to the left. It's all the way down here somewhere. All right. You could have written that in a different way. You could have said g of x has all its x-intercepts to the right of f of x's x-intercept. You can write it in any way of English you want, so long as you're explaining who is to the right, who is to the left. Are they all to the right? Are they all mixed together? Just a sentence to explain, that's all. Okay. Also, another thing to point out here, we've got 3 intercepts here. We've only got 1 intercept here for the x. So it says the graph of g of x intersects the x-axis more times than f of x, because this has 3 of them and this only has 1 of them. This has 1 x-intercept. This has 1 here. This has 1, 2, 3. So a very simple thing to just note down. It's just to see if you understand. What about the y-intercept, which is about how high up the graph cuts the y-axis? So this is at 1.5 and this is at 4. So obviously g of x is going to be much higher. So the y-intercept of f of x is less than the y-intercept of g of x. You could have written that the other way around. G of x is higher than f of x. Just give me a sentence to explain which one is above the other one. Okay. Again, they've said, so g of x intercepts the y-axis at a higher point than f of x. It's almost repeating, double the amount of sentences you have to write. So we've done these two. Now we need to do the relative max and the relative min. When you have a graph and you have one function and then you have another function, okay? So I've deliberately made it so that this is higher than this. You will just tell me f of x is higher than g of x. Okay, the max for f of x, don't forget to call it the relative max. For instance, I'm giving you an example here, is higher than the relative max of g of x. What about here? What do we mean by higher? This is higher than this one. So you would say the relative minimum is higher for the g of x than f of x. So look at it literally as how high you are on the y scale. So let's have a look what they say. We've got a maximum of 4.7 compared to a maximum of 4.2. So f of x has a higher relative maximum. So the relative maximum of f of x is greater than the relative maximum of g of x. What about the minimum? This is 1.1, this is minus 1.2, so this is bigger. So f of x has a higher or greater relative minimum than g of x. The relative minimum of f of x is greater than the relative minimum of g of x. Remember, it's basically how high you are on the scale, how high up you are. Okay, and what did we see about the end behavior? They were both the same, so that's nice and easy. The two functions have the same end behavior. So it's one thing being able to write the notation, but do you actually realize they're the same? Can you write that as a sentence in English? It's literally as simple as that, girls. It's more hard work in terms of more writing than it is actually complicated. It's quite a simple concept. But take your time, spend some time tonight, do 3 or 4 questions until you're confident and you can do it quickly. Nobody's going to tell you if you've missed any of these out. You'll just lose marks in the exam. So please make sure that you write these down. Make sure you include all of them. So the difference is, for linear, it's just 3 things to do. X-intercept, Y-intercept, slope. For non-linear, we've got X-intercept, Y-intercept. We're not going to compare the slopes now because the slopes keep changing. We're going to do where's the relative max, where's the relative min, what's the end behavior like. Okay, so that's that one. I've just put at the bottom here a picture to remind you that I've given you question 14, 15 and 16 in ClassKick. Please have a go at those questions, either in ClassKick to send me, or you can do them in the book and send me a picture, but let me know how you get along. Follow, almost carbon copy the example given, but with your numbers in. Okay, have a go at that. Thank you, girls.